Hey guys, welcome back to the channel. Now this is the second part of the little electrical system that I'm installing at the moment. There's a lot of Victron stuff going in, so I really like the Victron stuff. That's really exciting, the way it's all coming and connecting together there. So this is the board that I've made up essentially for a lot of different reasons. For the solar panels, for the monitoring systems, for Wi-Fi, for backup systems, for the chart plotter, all different things like that. But let's go through it bit by bit and I'll explain how it works. So we'll start off in this area actually, and this is where the solar panels are connecting to these fuses down here as well. So you can see the red and the black there, plus and minus. They're just going to basically connect into these individual ports there, just with crimp connectors basically. I was tempted to use DC breakers for all of these, but they are a tad bit expensive and I just want to keep it pretty simple and keep the weight down a little bit as well. So I just ended up, I had this little fuse block here anyway, and I just thought, well, why not use it and then just put some fuses in there, both for positive and negative. I wanted to put the fuses there for the positive and negative sides, just in case I get any spurious connections or anything weird going on, it will just break that fuse straight away. So for the solar inputs there, I have seen some people using AC circuit breakers as well, and they have been known to work, but to be honest, I would always go with a DC breaker there, just to make sure that there's no arcing inside the breaker and any potential for a fire or anything like that. So I've just gone belt and braces here and just made it standard fuses. There's not too much voltage going on here or amperage or anything like that per individual circuit here. It's not too much of a danger, but still, this is the way I wanted to build it. So yeah, I was really tempted to use these AC breakers, and I did see some tests on YouTube where they were working, but a 10 amp fuse was more or less breaking at 12 or 13 amps as well. And I just didn't want that in the back of my mind. I chose just to go with some DC breakers here instead of the AC. Essentially the 3 solar panels I've got on Aurora come into these fuses here. I've got a port and a starboard 55 watt panels, and I've got a middle 78 watt panel to connect as well. So that comes to, I think, about 2/3 of the power that this can handle. And on top of that as well, I've got a 150 watt portable solar panel as well that you saw me using last year. So I've got 4 ports there for all of those panels coming in. And they come into a bus bar here. Let me just remove this one. That essentially means that they're all going to be connected together here, making a parallel circuit. From the bus bar, they go straight into the charge controller here, and this is a 100 volt or a 20 amp charge controller from Victron, a super nice device actually. And then it comes out of the charge controller through this DC circuit breaker here. This is a 20 amp DC circuit breaker, and then out to the batteries there. I've also got a little earthing bar up here, so I can connect the MPPT controller to the earthing bar, which will then be connected to the main earth bar, which in turn will be connected to the keel. So pretty much the best earth on the boat is either the keel or the engine. The MPPT controller here can connect via Bluetooth, and it can connect to the servo as well. I'll go on to that in a minute, via a VE direct cable, which gives the servo all the information it needs about power coming into the boat from the solar panels as well. Of course, when you're speccing out an MPPT charge controller here, you need to calculate the maximum volts and the maximum amps that you will be expecting to receive from your solar panels. Just make sure that this won't get overloaded and overheated all the time, especially if it's in a small compartment or something. It's always best to let a bit of airflow go over this thing as well. It's got a big heat sink on the back also. Then down here, we've got a Victron Servo GX. Now this is an awesome bit of kit actually. This will take multiple inputs around the boat and give you a lot of data from that as well. So just going through the connections on this device here, you've got tank sensors here. Now these are resistance sensors. I think they're between 0 and 190 ohms if I remember correctly. And that will determine, or that will tell the device, depending on what resistance comes back from that sensor, it will tell the Victron Servo, okay, how full is the tank? And you can see that through a variety of different methods. You can see it via the the touchscreen display that they provide. I think it's called the GX Touch 50. You can also export the data as well to any data collection device that you can think of. I'm going to be using the Raspberry Pi here, but I'll talk about that a little later on in another video. Actually, that's a whole topic on its own. But you've also got the temperature sensors as well. Again, these work in a slightly different way on the Cerbo. This outputs a 5-volt signal to any temperature sensor that you have. Victron do sell a temperature sensor that you can connect to this, and you can extend the wires somewhat, but I have gone ahead and actually built my own. So these are the temperature sensors I've made, and basically it just contains two components. This LM335 component there that Victron have kindly put in their wiring diagrams, because they're all about open source and sharing information, which is really nice. And then a 10k ohm resistor as well, and you just wire them all up basically, but essentially it's just connecting these up. And the reason why you need this 10k ohm resistor is to vary the feedback voltage from the temperature sensor basically. You have to do this because the length of wire that you're leading back to the Cerbo is going to affect the voltage that's coming back from this device. So basically when I'm installing this, I'm going to take a comparison sensor that I know is good, compare it, and then adjust the potentiometer inside here so that it matches the known good sensor. And yeah, then it should be calibrated and we can install it in all of the locations. But yeah, let me tell you, this took quite a bit of time to get all the right things in the right places, because it's very fiddly. And it's not going to save you that much money, but it's the only way that I could think about doing it, to be honest with you. And yeah, your soldering skills have to be fairly okay for this job, unless you can crimp it in some way or use some terminal blocks in some other way as well. So those were the temperature sensors I built, specifically because the wiring lengths were quite long, and you need to put that potentiometer on there to adjust the voltage return so that you can calibrate all the temperature sensors so that the temperature will be accurate basically and not out by any number of degrees. With digital inputs, I've had a little look on this, and it's expecting an on or an off in a 5-volt voltage switch basically. I was trying to use the digital inputs maybe for sensing whether the build pump was on, but there's a little more complication to that. I've got to do a little bit more reading there, but it could be useful. And then there's relays as well. You can turn generators on and off, other devices as well using the relays, and you can do this all remotely. Like I said, with the 4G solution that I talked about in the last episode, I can connect through that. I can connect to the Cerbo and control these relays as well if I really want to. That's going to be super convenient. The power in is between, 8 and 70 volts DC, so you're good on a 12 volt or a 24 volt system. There's an Ethernet port on the back. There's 3 VE direct ports. Now these are used for talking to the MPPT controller. They're used to talk to the Victron shunt as well, and it'll allow the Cerbo to see exactly what power is going in and what power is going out of the batteries as well. And then also we've got the VE bus, which I will use for the inverter that I'm going to be installing as well. I'll get onto that in a minute. That will be used to see exactly how the AC voltages are doing, and to see exactly how much power that's drawing out of the batteries also. There's a bunch of other connections as well. There's plenty of resources online for the Victron Servo. I originally started building my own actually using the Raspberry Pi, but pretty quickly I saw how much work and how much effort has gone into this device, and how difficult it is to build your own systems and start playing around with the electronics and everything. It requires quite a lot of knowledge. I could have done it, but I simply don't want to, you know. In my work profession, I've learned to use the right tools for the right things, and sometimes just to make it easy for yourself. Now, a good comparison here is between, let's say, a Windows machine or a Mac machine and Linux. You're always going to have a harder time with a Linux machine because everything is so bespoke and so configurable, but you've got to do a lot of the work yourself, and it's just, sometimes you just don't have the time to get involved in every single little detail. So this box takes a lot of headache away from you in that regard. You could do it all yourself. Victron have actually been really kind in providing all of the software that goes on, well, most of the software that goes on the Cerbo GX as open source. So they do provide an operating system, actually, that you can install on the Raspberry Pi and do this all yourself if you really want to, if you want to go down to that technical level. The Raspberry Pi, now this is going to run a bunch of stuff, actually. First of all, I'm going to install, well, I've already installed OpenPlotter on it, so you'll have a backup navigation chart device, basically. There's Signal K that you can put on that, which will take all the NMEA data for you, and you can compile that in various ways if you want to. I have also installed Victron, the Victron Docker images that they provide with Grafana. So Grafana is going to take all of the data from the Cerbo, and I can display that in a really good way on the screen in the boat. I'll show you all of this in a separate video. It's super exciting and it looks really cool. You can see all of the tank levels, you can see the battery histories, you can see inputs and outputs, all on a big screen. And finally here we've got the RUTX10. This is also an awesome device because it will provide the Wi-Fi, and it can also do all your DHCP requirements, all your VPNs, everything like that if you really want to as well. But essentially I didn't need Wi-Fi at the top of the mast, so I chose that device for just the 4G at the top of the mast. And this RUTX10 will do all the Wi-Fi inside of the boat, and it's a pretty powerful Wi-Fi transmitter, so we shouldn't have any problems there. And you can use it as a switch as well, so I'll be connecting some things with the Ethernet cables directly into the switch there to guarantee a good connection, really. In my opinion, it's always better if it's not too much hassle to connect everything via Ethernet, because then you've got no discrepancies on whether it's connected or not, or whether there's any signal interference. You know that it's going to connect, basically. So essentially what's going to be connecting into this router here is the Raspberry Pi, the Cerbo GX, the multifunction display, the chart plotter basically in the cockpit as well. And this is so everything can connect to the internet and do all the updates, everything that you need to do, and it's just all connected, right? And there's a lot of cool things that I'm expecting to happen from having all of these devices connected together. For one, I think the multifunction display, the BNG one, will start displaying some Victron information as well. I'll also be able to start capturing all the NMEA data as well, because the chart plotter is actually going to start broadcasting that over the network. It's going to be really exciting, and yeah, it might sound sad and geeky and whatever, but yeah, this is going to be a lot of fun for me. It's what I enjoy doing. As long as it's not too deep and it doesn't involve weeks of research to do a simple thing and everything just connects and it works nicely, I'm good with that. It's a bit of a hobby of mine. One more thing I forgot to mention here as well is this DC step-down converter. It's a pretty simple device. Not many companies are actually, or I didn't find that many companies that are doing a 12 volt to 5 volt step down converter for a USB-C connection. So I eventually found this company called Connected in the US, and yeah, I just connect my 12 volt supply, it steps it down to 5 volt, and it's a nice USB-C connection there. So essentially that's it for this setup. I'm really looking forward to showing you guys when it's all connected, when all the displays are on and everything, and I've set up my Grafana displays and we can see all of that information. It's going to be a super cool setup, or at least I think so anyway. I can see a lot of data from that. You know, I've got temperature sensors connected in the fridge, in the freezer, in the engine room, outside. Anyway, there's one final thing I want to show you, and this is really cool. Let's go and get that one. Check this out, guys. This is a Multiplus Compact 12 2000 watt 80 amp charger. It's going to be a really cool addition to the boat. Yes, there is a charger on board, but this is going to enable me to convert the DC from the batteries to all of the AC sockets at all times. And it's going to complete my Victron collection, basically. I've got a little bit of an OCD problem there where, you know, when you see the Victron Servo display and it doesn't have an AC voltage display on it, yeah, I need to complete the collection right now. Jokes aside, this is going to be a nice little upgrade for us. And what you have to think about when you're speccing up an inverter charger is the maximum loads that you're going to be looking at. And I've had a quick look around actually, because one of the maximum loads that I can think of that we'll be putting on the boat is probably a vacuum cleaner or an induction cooktop, which one day we might convert to, or an electric oven or something like that. They will be really big power draws for the system. Now, as I've got this for the electrical system, I bet you can guess what the next upgrade is going to be. It's not going to be just yet, but we're going to start looking at the batteries maybe one day. But we're just going to get the use out of the batteries, the AGM batteries that we've got on board, as they're, you know, only 2 years old now. So we'll get the life out of them. And then eventually we're going to be looking at lithium. And this is going to be a really good addition for the lithium here, so we can get the maximum out of those batteries also. I'm looking forward to that installation, but one thing at a time, guys. But this should be a fairly simple installation. I'll do this over the next few weeks and I'll show you it all when it's all hooked up together. Okay guys, well, thanks very much for watching. I hope you got something out of this episode as well. I've gone over everything very briefly. There was a lot of thinking and a lot of research gone into me building this one. I'm actually quite proud of this little puppy. It's going to be a really nice installation, I think. It's going to sit just behind the couch seat on the side of the hull. So I've got to Sikaflex some mounts into there and yeah, just mount it in basically. But as before, if you have any comments or questions, or if you've got any advice actually, I'm all for taking advice from experienced sailors, that's for sure. Thanks very much for watching guys. Drop us a like if you like this video, and yeah, I'll see you next time. Thanks then. Bye now.